Hi everybody, these notes are about combustion reactions. Today's date is whatever the date is, you figure that out. So please date and topic your notes if you haven't already. Okay, so to start off with, we're just going to review a few things about chemical reactions. So again, a chemical reaction occurs when something new is made. That means our atoms have separated, combined, or rearranged. But again, how can we tell that atoms are separating and combining or rearranging if we can't see what they are actually doing because they're so small? Well, lucky for us, as we learned in first trimester, the atoms leave us signs. Here are some different signs of a chemical reaction. So if we see an unexpected temperature change, getting colder or hotter, an unexpected odor, an unexpected state change, things like gas bubbles or a precipitate, a solid that's falling out of solution, or an unexpected liquid being created. Those are all examples of chemical reactions happening. We also have the possibility of light being given off, as well as an unexpected color change. All of those things tell us that atoms are separating, combining, or rearranging. So when atoms do that, when they separate or combine or rearrange, they actually do it in a number of very predictable patterns. And those predictable patterns we refer to as types of chemical reactions. And so over the next several days, we're going to go ahead and we're going to think about different types of chemical reactions: combustion, synthesis, decomposition, single replacement, and double replacement. Today we're going to focus on the first of these, which are combustion. Okay, so a combustion reaction is a reaction. That word combustion, when we think about it, usually we think about it and it means some kind of fire, right? Some kind of fire. Combustion means burning or explosions or things like that. So a combustion reaction is a type of chemical reaction where a hydrocarbon means that it's got hydrogen and carbon in it, combines with oxygen to make carbon dioxide and water. It often involves burning, but doesn't always involve burning. Okay, so in other words, we've got some kind of fuel, we combine that with some kind of oxygen, and what we get out on the other side is always water and carbon dioxide. So as I just said, a hydrocarbon is any molecule with hydrogen and carbon in it. So here are some examples over here. Here's methane, propane, ethane, butane. They're all made of carbons and hydrogens. And when we take those and combine them with oxygen, we always get the same products. Those products are always carbon dioxide and water. Okay. This kind of reaction, a combustion reaction, happens in burning fuels, and it also happens in using fuel in living things. Okay, so we're going to go ahead and we're going to do a few examples of a combustion reaction. The very first one is burning methane. And hopefully we should have a video for you of methane bubbles being produced. And so we're going to go ahead and we're going to deal with a methane bubble reaction. So CH4 is methane, O2 is oxygen, so hydrocarbon and oxygen. And as we said, the products are always the same. They're always carbon dioxide plus water. All right. So when we go ahead and we do that, we then end up with this reaction equation. Last thing we have to do with any equation, though, is make sure it is balanced. So 1 carbon, 4 hydrogens, 2 hydrogens. So I'm going to put a 2 out in front there. Last but not least, we have 2 oxygens on this side. Over here we have 2 plus 2 oxygens, which is 4 altogether. So we're going to need a 2 out in front of that. Okay. When we do that, then we have our balanced equation for our combustion reaction. Another common example of a combustion reaction is lighters. Okay, lighters inside them contain a chemical that we call butane. Butane is C4H10. And when we combine that with oxygen and a little bit of spark, we get the flame that comes out of the top of a lighter. Right? So this kind of combustion happens with any kind of alcohol, like methanol, ethanol, isopropyl alcohol. Any of those can combust in the same way. So let's go ahead and let's do the butane reaction. So C4H10 plus O2. And again, our products are always CO2 plus H2O. So there we go. We got our products written, and now all we need to do is balance. So C4, so 4 carbon. Over here we need 4 carbon. 10 hydrogen. Okay, 10 hydrogen means that I've got to put a 5 in front of this. Oxygen, I've got 2 here, and 8 plus 5 over there, which is 13. That is an even odd problem. So as we learned when we were balancing reactions, we're going to go ahead and we're going to double the odd. The odd is coming from this 5. So that means that I'm going to go ahead and I'm going to take this 5, erase it. We're going to double that, and we're going to make it a 10. Okay, and then we go back to the beginning and we start over. All right, so now we go ahead and we keep balancing. Okay, and so we've got 4 carbons, 10 hydrogens. Oop, now we've got 20 hydrogens, so I need to put a 2 out in front over here. And now I've got 2, and over here we've got 8 plus 10 oxygens, which is 18. So I'm going to put a 9 in front there. Going back to the beginning to keep balancing, make sure we got things going on. We now go ahead and we have 8 carbons. Over here we only have 4, so I'm going to go ahead and we're going to put an 8 in front of this. And then we go 20 hydrogens, and now we need to do oxygens. Okay, so over on this side we've got 18. Over here we've got 16 plus 10. That equals 26. So we need more oxygens over there. So that tells me that I've got to go ahead and I've got to change this number out in front in order to get me to 26. And in order to do that, we need a 13 out in front. Okay, so we go ahead and we already take rid of that. There's an example, another example of how to balance a combustion reaction. A few little side notes about fire and combustion. When we go ahead and we burn things, depending upon the oxygen content or how much oxygen is being combined with the hydrocarbon, we get different flame colors. And as we get warmer, we get flame colors that are higher and higher and higher and higher. And so the hottest flames are those that are in the blue color. The coolest flames are those that are in the red color. And so that's what we see when we're in a Bunsen burner. If we're making a Bunsen burner, we want to make sure that we go ahead and we have a blue cone flame inside because we know that that is the hottest. Why do we get other colors? Because sometimes we get complete combustion and sometimes we get incomplete combustion. What does that mean? Well, when in the cases of incomplete combustion, not all of the hydrocarbon burns up cleanly into carbon dioxide and water, whereas in complete combustion, they do. And so you end up with a situation over here where you have, if you have complete combustion, if you have enough oxygen, you can go ahead and you get carbon dioxide and water only as a product. But if you don't have enough oxygen, what happens is you get a mix. You get carbon dioxide plus water, but you also get a poisonous gas called carbon monoxide. And you also get a little bit of carbon, which is like soot that comes along on this side. And so that happens sometimes. And so like if you have a furnace in your house or something, you always want to make sure you have complete combustion because then you're not making this toxic gas, carbon monoxide, or carbon soot that goes along with it that can like dirty up and make your furnace not run as efficiently as it was before. A couple other facts about fire. We talked about complete and incomplete combustion. We talked about flame color. Last thing I'm going to talk about is fire triangles. If you ever go and look at a fire extinguisher, you will see that on the side of it, it has different letters that can be used in order to tell it what kind of fire extinguisher it is. And each of these letters corresponds to what kind of fire the fire extinguisher will put out. Most fire extinguishers that we see in like houses and whatever else are ABC fires, meaning they can take care of regular fires, they can take care of flammable liquids, and they can also take care of electrical fires on top of that. But there are a few other special kinds of fire extinguishers out there that depending upon what you're going on, what you have going on, and what your risks might be. All right. So a couple more. This is ethanol. ethanol is an alcohol, and we oftentimes do a demonstration called the whoosh bottle. Hopefully we have a video of that for you. And with that whoosh bottle, we're going to go ahead and we're going to show you what the reaction of that looks like. So here's our hydrocarbon, and we know that we're going to react that with oxygen. And on the other side, we get carbon dioxide plus water, because that's what we always get in a combustion reaction. Then we're going to go ahead and we are going to balance this equation. So 2 carbons on the left, 2 carbons on the right. 5 plus 3, that's 6 hydrogens on the left. Go ahead and put a 3 there to give us 6 hydrogens on the right. And over here I have 1 plus 2, which gives me 3 oxygens on the left. Over here I have 4 plus 3, which gives me 7 hydrogens on the right, oxygens on the right. So I need to add more oxygens on this side, and the easiest way to do that is just to add oxygens over here. So I'm going to go ahead, I need 4 more, so if I'm going to go ahead and put a 2 there, that gives me a 1 plus 4. That's not quite what I want, so let's go up to a 3. That's 1 plus 6. That gives me a 7 on this side. So in the end, what do I have? I have 2 carbons, 2 carbons, 6 hydrogens, and 1 plus 6 oxygens is 7, and 4 plus 3 oxygens is also 7. One more example. Methanol cannon. Again, hopefully we have a video of that for you so you can see what that kind of reaction looks like. And then on top of it, we're going to go ahead and we're going to balance this out.